We have notes today for objective 1.6c. We use the distance formula to find the perimeter of shapes in the coordinate plane. So our essential question is, how do I find the perimeter of shapes on the coordinate plane? So, a couple things we need to remember about stuff. So, Pythagorean theorem, we've been doing that. It's when you have a right triangle. This is C, A, B. Remember that C is always the side across from the right angle. The distance formula, label your points. And of course, the perimeter is just where we add up each of the sides. So I want you to think of a fence. Think of a fence. We're looking at the distance around something. That's what perimeter is. All right. So we're going to start with this triangle. We have triangle ABC. Vertices are the endpoints here. And we're going to find the distance all the way around. So as we do that, we have to find the distance of each piece. So A, B, and C. So we're going to find the distance for AB, the distance for AC, and the distance for BC. So as we do that, we need to label our points so that we go through and find each one. So I'm going to do it in different colors because we're going to label more than one set of points, x1, y1. So we're going to be careful as we're labeling these. So let's start by calling A x1, y1, and B x2, y2. We'll do that one in orange. So the distance formula, remember it's back up here. It's x2 minus x1 squared plus y2 minus y1 squared. So we're going to say this is the square root of 2 minus a negative 7 squared plus negative 5 minus 4 squared. Now remember, we can put that all in the calculator, get it all the way nice and pretty. And then we can go to Desmos. So we do square root, parenthesis, 2 minus 5 squared plus, let's go back and look at the number again, negative 5 minus 4. And this is a 7, not a 5. Minus 5 minus 4. We go back and make sure. Minus 5 minus 4 squared. Except I need to make sure that's all the way under the radical and it doesn't look like it. So plus minus 5 minus 4. See the difference now between how the radical is? And so we're 1 in the nearest tenth. But for this first one, I'm going to put 8.48 because we're going to round when we're all the way done. So I'm going to put 8.48. So we come back here and this is 8.48. So when I'm done, I'll do that, but for each one, I'm going to do 2 decimal points until I'm finished. So let's change colors, because now we're going to call x1, y1 for A, but this time C is x2, y2. So that's 5 minus a -7 plus -1 minus 4 squared. So 5 minus -7 and -1 minus 4. So we'll go back to Desmos. And we have the square root, parentheses, I can't remember the numbers already. 5 minus a -7. 5 minus -7. See, and it took me out. I gotta go back in there and make, that's not what I want. Make sure that it stays under the square root. 5 minus -7 plus -1 plus parentheses -1 minus 4 squared, and this time we get 13. It's a perfect square root, so we can just leave it like that. So we get that this is 13. And now we're going to do the final one, and we're going to call BC, or B, x1, y1, and C, x2, y2. So this is the square root of 5 minus 2 squared plus -1 minus a -5 squared, 9 plus 16, that should be 5. So it's 5 minus 2 squared and -1 minus a -5. 5 minus 2 squared, oops, plus -1 minus -5 squared, and we get 5. So when we add them all together, total perimeter is 8.48 plus 13 plus 5. That's 18 plus 8 is 26.5. So you can see this isn't much different than what we've been doing. It's just the distance formula multiple times. The trick is, as I've done here, to name the points x2, y2, and maybe do it in different colors or go back and erase as you go through so that you end up with the numbers and using the right coordinates in the right place. That's the hardest part about this. Now, this next example is a parallelogram. Parallelograms just mean it has 4 sets of parallel sides. They don't have to be right angles. This could be a rhombus. It could be all kinds of things. First, we have to plot them. I don't suppose I really have to plot them, but it does make it easier to do this. So -2, -1, that's A, or sorry, P. I'm calling this PQRS. Q is -1, -5. R is +5, 3. And 4, 7 is S. So we end up with this shape here. So again, I'm just going to go through and do the distance formula 4 times. So we have P, actually I only have to do it twice, because if they're parallel, they should be the same distance. So I'm going to find PQ, and then I'm going to find PS. So this was -2, -1. Q was -1, -5. And S is 4, 7. So let's do PQ first. When I label these, this is X1, Y1, X2, Y2. So that's -1 minus a -2 squared plus -5 minus -1 squared. That's 1 plus 9 is the square root of 10. Let's go back to Desmos. It's the square root of 10. It's 3.16. Now notice that this question, this one says 2 decimal places. So this was 3.16. Now we're going to find PS. We're going to change colors. So I'm going to leave this X1, Y1. I'm going to make this X2, Y2. So that I have 4 minus a -2 squared plus 7 minus -1 squared. That's 6 squared plus 8 squared. The square root of 6 squared plus 8 squared is 10. So this is 10. Now, when I find the perimeter, I have to do PQ plus PS plus SR plus RQ. PQ is 3.16, so is SR. And then PS was 10, so is RQ. So 26.32. So I can say that these two sides are the same because they have to be parallel. And these have to be parallel. That means the sides have to be congruent. So that's why I could say that those were congruent. All right, let's look at a couple more examples. We're given a quadrilateral, rectangle it says. Because it says the word rectangle, just remember your vocabulary. That means these are 90-degree angles. Parallelograms don't have to, but rectangle does. Not that it matters, but again, that verifies that those are congruent and that these are congruent. And we're doing nearest tenth again. So we have to find W is 4, -3, X, Y, and Z. So to find WY, and then I'm going to find WX. And then I'm just going to multiply that by 2. So I'm going to call WX1, Y1, and YX2, Y2. So that I have 4 minus a -4 squared plus 3 minus a -3 squared. That's 8 squared plus 6 squared, so that's 10. And then I'm going to label this X1, Y1, X2, Y2, so that I can have -1 minus a -4 squared plus -7 minus -3 squared. So that's 9 plus 16, that's 25, that's 5. So the perimeter is going to be WY plus WX plus YZ plus ZY, nope, yx. So this is 10. That means this is 10. Nope, I did those wrong. This is 10. This is 5. This is 10. This is 5, and this is 10. So we have 30. Now it says 1 decimal to the nearest tenth. Just make sure that you check and make sure whether we want 30 or 30.0, especially on tests. Again, it's just the distance formula, repeated. Making sure that you label your points and either erasing those or going back and using a different color, crossing them out, something so that you know which one you're dealing with at the time so that you can keep your points straight. The last shape we're going to talk about is a triangle. So we have LMN, triangle. L is at -3, -1. M is at 2, 0. And N is at -2, +6. So there's my triangle. So again, we're just going to make sure that we're careful with our labeling. So I'm going to call this x1, y1, x2, y2. So we're going to find NL, NM, and LM for our lengths. This is a triangle, and I don't have a name for it. It's not called an isosceles triangle or an equilateral triangle. I'm going to have to find all three sides. So NL, we have -3 minus a -2 plus -1 minus 6. That's 1 plus 49. It's the square root of 50. So that's 7.07. Now this one's asking, it doesn't give us a thing. So I'm going to stick with the nearest tenth. Unless stated, always do 1 decimal point. So I'm just doing 7.07 just because you start out bigger than you need to be when you're finished. So then we're going to find NM. I'm going to change colors. I'm going to leave N x1, y1, so I'm going to make N x2, y2. So that's 2 minus a -2 squared plus 0 minus 6 squared. That's 4 squared plus 6 squared. That's 7.21. And then finally, we're going to finish it off with labeling L x1, y1 and M x2, y2. So that I get 2 minus a -3 squared plus 0 minus -1 squared. That's 5 squared plus 1 squared. It's 26. So I need the square root of 26, 5.09. So when we add it all together, that's 7, 8, that's 17, carry the 1, 3.14, 19.37. That's 19.4. So, as we're talking about our summary and thinking about what this means, I would go back to our essential question, which is, how do I find the perimeter of shapes? I probably should call those polygons. On the coordinate plane. So to find the area, the perimeter of a polygon, I need to find length of each side. Remember to label carefully and add all sides for a perimeter.